So are you able to see the virtual blackboard?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay, fine. So whenever you have any doubt or you want to say something, you please raise your hand. Okay. Okay, so we have completed the operation of diode part, and then next we have to move to its application part, because we have a fabricated device for some specific applications. Okay, so now we will be discussing that thing. So next topic of next chapter of Boylston, that is diode application. In this we will be studying first load line analysis, then series, parallel, and series parallel configuration of diode. If the diode is in series or in parallel, or we have both series parallel combination in the circuit, so how to solve this. After that, rectifier. In this we will study half wave rectifier, full wave rectifier. Rectifier are used for AC to DC conversion. It is a part of AC to DC conversion circuit. Next is clipper and clamper. So these are some applications that we are going to discuss. Diode has many more applications like logic gates, amplifier, switch. Okay, but according to our syllabus, we will be limiting our discussion to this few, 4 or 5 topics. So starting with load line analysis. Okay, so let me take an example before starting this. So let's say we have a two curve y equal to x. Okay, and the second curve is given by y is equal to let's say ax plus b. So both are linear curve. Okay, you can solve them easily. You can solve them by putting y equal to x, and suppose this is equation 1, this is equation 2, so you can put y equal to x in equation 2. So x will be equal to a of x plus b, and x will be equal to b upon 1 minus a, like this, and that will be also equal to y. So if you have two linear equations, you can solve it very easily. Case 1. Case 2, if you have equation like y equal to x, and second is let's take a circle like this, x square plus y square is equal to 4. Okay, so now solving this is not that easy. Although I have taken simpler equations. Okay, but if this equation is somewhat complex, then you will be you have to do many calculations. Okay, this is non-linear equations, kind of a quadratic equation. So this can be solved easily. You have to just put x equal to y. So 2x square will be equal to 4, x square will be equal to 2, x will be equal to plus minus root 2. So this although I have taken simpler equation, but you can see that you have to take square root and then you have two values. Okay, and if I take a bit complex equation, then you will have to add few more steps. Okay, so this is how you can solve it mathematically on graph and paper. Second method is to solve this is graphically. So you might have done earlier. So what you have to do in this, you will draw their curves. This is equation 1. So you will draw a curve for equation 1. So it is a straight line passing through origin. Slope is 1. So this is y is equal to x. And this is a circle with radius. Okay, with some radius r, like this. So this solution the value of x and y is nothing but the intersection point of these two curves. It is simply the intersection point of these two curves. So you have to draw these two curves on same axis, y axis, x axis. So this is your circle, and this will be your y equal to x line. So you have two solutions. First one is this in first quadrant, second one is this. Okay, and you are getting two values, positive x, negative x. That will be also equal to y. Okay, so now we will be using this technique. We will find intersection of curve to find the values. Okay, so where we are going to use this technique? To calculate the value of ID and VD. Okay, so a very simple circuit is given with voltage, external voltage source E. E is obviously greater than Vk. E should be greater than Vk to make this diode conduct. Current ID is flowing, and voltage drop of plus minus Vd. This is the polarity, plus here, minus here. This is the voltage drop across the diode, and this is the external resistance R. So what we usually do, we either take ideal diode. What we have done till now, we have taken ideal diode or simplified model. Sorry, simplified model. In the simplified model, what we are doing, we were assuming that Vd will be always equal to Vk. We have fixed one value. And third case, piecewise linear model. Okay, so in both the models, we are fixing that Vd will be always equal to Vk like this. But this is not the actual case. This is the original equation, ID versus Vd. This is Vd versus ID. So for different values of Vd, you have different values of ID. So instead of taking the actual characteristics, into the account, what you have done, you have assumed that Vd will be fixed, Vk. It is not changing. No matter whatever is the value of E, if E is greater than Vk, Vd will be always equal to Vk. But this is wrong. Okay, this assumption we have made for our own simplification. Okay, in actual, there is a various option, various values of Vd, and for various values of Vd, you can have different values of ID. So you have done experiment number 2. In that you have verified. Okay, for different values of V, you have different values of Vd and ID. Although variation in Vd after Vk was not that much, but still values were different. It was not like fixed at a point. Okay, so to have actual characteristics, now we need to find out the actual characteristic, not like this Vd is equal to Vk. What is the actual value of all the possible values of Vd? So what will be the exact value of Vd and the corresponding ID? Okay, so what we have to do for this? We have to solve these two equations. So these two equations are, first equation ID, Vd. We have diode in our circuit and ID is flowing from P to N. So that relation is given by ID is equal to IS, reverse saturation current. In bracket, we have e raised to power Vd. Vd is voltage drop across this diode divided by eta Vt minus 1. Okay, so now you cannot simply fix this Vd. This is equation 1. Second equation can be obtained by applying KVL across this loop. So E is Vd plus ID Rd. This is equation 2. So this is by KVL. In this two equation, E is given, R will be given. Okay, E is given, R will be given. So you have two unknowns, Vd and Id. And in first equation, Is will be known to you. Is is fixed for any particular diode. Vt, you know Vt, eta will be also given. So again, two unknowns, Id and Vd. So in equation 1 and 2, except for Id and Vd, all the parameters are known. So you have to solve this two equation for Id and Vd. Okay, so you can see that it is a linear equation. This is an exponential equation. It is not that easy to solve this two equation. Okay, it is not that easy. You have to rearrange this equation. Vd, you have to bring Vd to the left hand side, remaining terms to the right hand side. Then you have to substitute Vd. Then you will have Id, that will be equal to Is. On the numerator side, you will have again Is. So Id and e raised to power again some id. So you have to solve this equation, and it is not that easy. Okay, because of this reason, what we were doing, we were assuming the simple models. Okay, but does that means that we cannot find the actual value of id and vd? Okay, so this is not the case. The process is complex. We can find the actual value of id and vd first by mathematically, by solving on using pen and paper. Second thing, graphically. So it can be solved graphically by finding intersection of the two curves. This example that I have taken. This is equation 1, this is equation 2. Draw equation 1, draw equation 2, plot both the equation on the same curve, and the solution is the intersection of their 2 points. So the same method can be followed here. Okay, so we have to follow the intersection of the two curves, that is equation 1 and 2, drawn on id and vd axis. These two terms are unknown. We want to find id and vd. So this will be our y axis, this will be our x axis. Okay, so for equation 1, multiple times you have seen that it will be exponential equation, something like this. id is equal to is e raised to power vd by eta vt minus 1. So id and vd are unknown, all the quantities are known. So this will be some of the possible possible values. So we have drawn all the values. And second, e is equal to vd plus id into rd. So this is a linear equation, vd and id. So if you draw on vd and id, this will be a straight line with slope minus 1 by r. Okay, if you convert this into y is equal to mx plus c, so m will be minus 1 by r. Okay, you can rearrange this. So now you know that it will be a straight line with slope minus 1 by r. So something like this. Negative slope means something like this, positive slope means this, negative slope means something like this. Okay, so now what you can do, you need to find just two extreme points. If you know the value of x1 comma y1 and you know x2 comma y2, then you can join this 2 point. Okay, so that will satisfy this equation. So this point can be easily find. We can easily find this 2 points. Okay, this is vd axis. On this axis, id will be 0. Okay, on x axis y is 0. So on vd axis, id will be 0. So if you put id equal to 0 into this equation, if id is equal to 0, vd will be equal to e. Vd will be equal to e. E is external voltage source. We know this value. So this point, let us assume that this point is e. So this point is e comma 0. Okay, so we got one point, x2 comma y2. Similarly, we can find the second point, x1 y1. So what we can do, we can take this axis, id axis, and we know that on this axis vd will be equal to 0. Okay, so put vd equal to 0. So id can be given by e divided by rd. So this point will be 0 comma e divided by rd. So just join this 2 point. So this is the straight line curve for equation number 2. Okay, both are drawn on id versus vd axis. Now what you have to do, you have to draw both the curves on same axis. So here I have drawn both the curve on same axis, and let's say that this is their intersection. So this point is known as Q point. You have heard this term 2 lectures back, Q point. Okay, so at this point we say that the voltage drop across the diode is VDQ. So this point is VDQ, and the corresponding current is IDQ. Okay, so this is known as Q point, quiescent point. Quiescent means still, ठहरा हुआ. So this is the fixed voltage drop across the diode. If E is fixed, the voltage drop across the diode will be fixed. Okay, E and every other parameter like resistance, E, temperature, every other parameters are fixed that we have used for plotting this graph. Then this point will be also fixed still. So VDQ, and corresponding to this VDQ, we will have some IDQ. So we say that this is quiescent point or operating point. So VD is equal to VDQ, ID is equal to IDQ. Okay. Now suppose you change the value of E. If E, let's say new value is E1 and E1 is greater than E. Okay. So this E1 will be somewhat here. This E1 will be somewhat here. This is E, and this yellow color dot is representing E1. Okay, and correspondingly the second point you will have at, let's say at here, R is fixed, so you will, E is increased, so 0 comma E1 by R. So now this will be new curve in yellow. So this point, the point in green, this is VDQ 1 comma IDQ 1. So if external voltage is increased to E1, VD becomes VDQ1, that is obviously greater than VDQ, and ID becomes IDQ1, that is again greater than IDQ. Okay, so this operating point depends on two factors. First is E. If you increase E, the curve will shift from in this direction. Okay, in this direction, upward, slight upward direction. So VDQ will increase. So if E increases, external supply voltage increases, VDQ increases and IDQ increases. So this was the observation. Okay, if you remember your practical number 2 that you have done 2 weeks ago, you were increasing the external supply voltage and VDQ was slightly increasing, IDQ was increasing drastically. Okay, so this assumption VD will be always equal to VK, this is not valid. Okay, there will be always some error. To have some absolute value, we have to follow this protocol. Okay, but we will be using this again and again for simplicity. This was just for your information, that how we calculate the actual values. So first thing is E, external voltage source, that affects the operating point, and this point, let's say this point is Q1. Okay, the second thing, external thing that can affect the operating point is this R. Okay, if you consider that this is an ideal diode, so I will be simply E by R. So if you increase the value of E, I will increase. If you decrease the value of R, I is again going to increase. Okay, so this is affecting it directly, and the same effect can be seen here. Increasing the value of E increases VD, ID. And next, what if you increase or decrease the value of R? Suppose this is your graph, VD versus ID, and this was your curve for equation 1, and this was curve for equation 2. This is, let's say, point Q1, where you are having value VDQ1 comma IDQ1. This is E by R. So now E is fixed. Okay, earlier E increases, R was fixed. Okay, now what you are doing, E is constant, you are not changing the external voltage source value. Now you are changing the value of R changes. Okay, so R can increase, I am using this note. Okay, R can increase or R can decrease. So this point is fixed because E is constant. Now this point is not going to shift in the right or left direction. If you change R, this point is going to move upward or in downward direction. Okay, so if you reduce the value of R, if R decreases, E by R increases. And E by R increases means this point will move in upward direction for R decreases. So let's say that you have a new value of R1. Okay, you have R1 less than R. So this point will be E by R1. So the new curve will be something like this. First point here, second point here, just join this 2 points like this. And this will be the point Q2, where you will be having VDQ2 comma IDQ2. Okay, so you can see that it is obvious that if you decrease the value of R, I is going to increase. This was also happening here. In the ideal case, decrease the value of R, I is increasing. Okay. So second case, if R increases, let's say that you have R2 such that R2 is greater than R. So E by R will decrease. Decrease means it will shift to downward direction. Let's say that this is the new point, E by R2. So now again, you can join this 2 point and you will have Q prime. Okay, so you have Q1, Q2, Q prime. So VD Q1, ID Q1. For Q2, you were having VD Q2, comma ID Q2, and Q prime, you will have VD Q prime, comma ID Q prime. Okay, so you can see that this is a comparatively lower value. Okay, so this is increasing. This is increasing. Okay, and you can make one more arrow. So this V and I are increasing for R decreasing. Okay, so this point will be fixed. If you decrease the value of R, this point will move upward, and obviously the intersection will shift to upward direction. This will follow this curve like this. Okay, so you are having some different value that will be greater than the previous value, and if this value of resistance is increasing, then obviously the current in the circuit will reduce. This point will shift downward and this point will follow this curve again. So this is the concept of load line. Okay, just you have to remember you have to study this. Apart from that, you don't have to solve any given equation using the load line because it is very, very complex. So we will not be giving you to solve this kind of equation, like solve two equations are given and calculate the absolute value. So this is not given, even though in higher classes this is not given to you. So just for your information that this is the actual thing that we need to do. So next, after that, this is all about load line analysis. The second topic that I mentioned was series, parallel, and series parallel combination. Okay, so I think series will be very easy to you. Okay, parallel and series parallel, you have to take care while solving parallel and series parallel combination. Series will be very much easy, and I believe that you might have done it previously. Okay, so first part A, series combination. So series combination means we have connected our diode in series in our circuit. We have any circuit like this, and we have connected our diode in series like this. This is D1, this is D2, and this is external resistance R. So now D1 and D2 are in series combination. Okay, let us assume that D1 is silicon diode and D2 is germanium diode, and you have to use simplified model. Okay, simplified model for solving the values of I. So since you are using simplified model, Vk for silicon will be 0.7 and V of k for germanium will be 0.3. Okay, simple, nothing to worry about. Just you have assumed that voltage drop across the silicon will be 0.7, fixed voltage drop across germanium will be 0.3. Okay, so now you have to make sure that E should be greater than Vk silicon plus Vk germanium. These two are in series. Okay, so 0.7 plus 0.3 is will give you 1 volt. So this external voltage supply should be greater than 1 volt. Otherwise, this will be in off state. Okay, so if E is less than Vk Si plus Vk Ge, so if E is less than 0.7 plus 0.3, E is less than 1 volt, D1 and D2 will be in off state. And the equivalent circuit will be something like this. Both will be in off state. Replace the diode with open circuit. So this is E. This is the case 1. E is less than Vk Si plus Vk Ge. So E is less than 1 volt. E is less than 1 volt. Open circuit. So I is equal to 0. Vr will be also equal to 0. Very simple. Okay. Case 2. If E is greater than or equal to 1 volt. So this is the value of E greater than equal to 1 volt. You simply replace silicon diode by a 0.7 volt voltage source, and yes, Rishabh, to 1 minute, and germanium by plus minus 0.3 volt source and external resistance. So if E is equal to, let's say, 10 volt, assuming, and R is equal to 1 kilo ohm, so I will be given by 10 minus 0.7 minus 0.3 divided by 1 kilo ohm. So you will have like 9 by 1 kilo ohm. So 9 milliampere like this. Okay, Rishabh.
सर मेरे को बस एक बार पिछली वाली स्लाइड देखनी थी.
अच्छा ठीक है, ये लो. ठीक है, Rishabh, are you done?
Yes, sir. Thank you.
Okay, ये अब notes मिल जाएंगे आपको वैसे.
हाँ जी, हाँ जी.
Okay. Okay, so solving the diodes in series is very, very easy. So this was the one of the possibilities that diode can be connected in series in this way. Second possibility can be like this. Both the diodes are connected in opposite manner like this. This is R, this is E. Okay, and D1, D2. So now no matter what is D1 and D2, okay, one diode will be always in reverse bias condition. So in this case, D2 will be always in reverse bias condition. Although we can make this diode D1 in forward bias condition by appropriately choosing this E, but D2 will be always in reverse bias condition. So this circuit will be something like this. The equivalent circuit for this one will be something like this. So no matter if D1 is in forward bias, reverse bias, or whatever region, D2 will be always off, and you have to replace D2. You have to show it by open circuit, and ID will be always equal to 0, and VR will be also equal to 0. So either it can be connected in this way, same direction, okay, PN like this, or this. Okay, there are only two possibilities. And the second thing is that if these are in series in the same manner, same direction, if these two diodes D1 and D2, or you can have many diodes, you can have multiple diodes as well. I have just shown you the two diodes. So this E should be greater than equal to at least equal to VK D1. This E should be at least greater than or equal to VK D1 plus VK D2 to turn diode D1 and D2 on, to turn D1 and D2 on. Okay, so before solving, please make sure that this condition is satisfying or not. Okay, so if for this circuit the value given E is 0.9 volt, okay, if this is given to you, so 0.9 is less than VK1 plus VK2, so D1 and D2 will be off. Okay, and this will be the equivalent circuit. So no need to solve, simply ID will be equal to 0, that's it. So make sure to verify this condition. So second thing that we have to study is parallel combination. Diodes are connected in parallel. So parallel. Again, we will be connecting our diodes first in same direction, then in opposite direction, and then we will see what will happen. So parallel combination. Okay, so before starting that, a very basic thing is there that suppose you have 2 points A and B. Okay, so you cannot connect voltage source V1, V2, V3 of different values. Okay, this is invalid. Between these 2 points, we can only have one value of voltage, V. Okay, so this is invalid. but you can connect different values of current. N number of current sources can be connected in parallel, but n number of voltage sources cannot be connected in parallel. This is valid. Okay, and similarly, this is also invalid. I1, I2, I3. So this is a series. These three current sources are connected in series. So I1 should be equal to I2, should be equal to I3. So in this case, V1 should be equal to V2, should be equal to V3. Okay, so please do remember this. These are very, very basic, very simple and basic concepts. But because you ignore this and you end up in solving the given question in the wrong way. Okay, so please do remember this. That concept we will be using. So first circuit given to you is like this, E, and this is a resistance R. Now you have to connect your diode in parallel. So this is, let's say that this is diode D1 and this is diode D2, like this. Yes, Rishabh.
सर वोल्टेज वाले में हमें कॉम्बिनेशन ऑफ बैटरीज तो कराते ही थे, मतलब पैरेलल में। आप कह रहे हो कि वोल्टेज उसमें
सीरीज में होता है, कैसे होता है पैरेलल में?
नहीं, पैरेलल में सर होती है सर, उसको फॉर्मूला होता है summation of E1 upon R1 upon summation of 1 by Ri।
वो आप वोल्टेज डिवाइडर सर्किट की बात कर रहे हो। यहाँ मैंने एब्सोल्यूट वोल्टेज सोर्स लिए हैं, ये देखिए, एक मिनट, यहाँ R कहाँ है? यहाँ तो एब्सोल्यूट वोल्टेज सोर्स है। सिंपल सा लॉजिक है, मैं आपको एक एलईडी दे दूं। एक मिनट, आपके पास एक एलईडी है तो आप यहाँ पर एक बैटरी सोर्स लगा दोगे, फिर दूसरी लगा दोगे, फिर तीसरी लगा दोगे, सब अलग अलग वैल्यूज की। क्या ये पॉसिबल है? पॉसिबल तो है, बट दिस इज नॉट वैलिड। ये दो पॉइंट के बीच में एक ही वोल्टेज, आप वोल्टमीटर यहाँ लगाओगे तो क्या वैल्यूज देगा आपको? लेट्स से दिस इज 2 वोल्ट, दिस इज 3 वोल्ट, दिस इज 5 वोल्ट, और आपने यहाँ पे वोल्टमीटर लगा दिया, तो क्या वैल्यूज मिलेगी आपको?
सर रियल केस में तो सर वो क्या कहते हैं, नॉर्मल बैटरीज होंगी तो फिर वो उनका कॉम्बिनेशन का जो रिजल्ट आएगा वही वैल्यू देगा।
कैसे भैया?
वोल्टमीटर
कौन सा, मुझे भी बता दो कौन सा कॉम्बिनेशन होता है, मैंने तो आज तक पढ़ा नहीं, आपने कहाँ पढ़ लिया? क्या फॉर्मूला होता है, बताना जरा।
सर क्या कहते हैं, समेशन ऑफ EI अपॉन RI।
व्हाट इज RI?
रेजिस्टेंस, जो भी उनका इंटरनल रेजिस्टेंस होता है बैटरी का,
RI
अपॉन सिग्मा ऑफ 1 by RI।
सिग्मा ऑफ 1 by RI।
हाँ जी।
ओहो, ये वोल्टेज डिवाइडर वाला कॉन्सेप्ट लगा रहे हो यहाँ, करंट डिवाइडर रूल लगा रहे हो आप यहाँ पे। ये वोल्टेज डिवाइडर थोड़ी है, V by R तो करंट होता है ना। देखो ठीक से पढ़ना इसको एक बार ठीक से। दिस इज ओके, पढ़ के आना उसको। यस नीरज।
सर वो सही कह रहा है कि अपन लाइक बैटरीज को, लाइक बहुत सारी बैटरीज को कंबाइन करके एक बैटरी बनाने के लिए ना हमारा रूल होता था कि उन सब की वोल्टेज वगैरह और उनका इंटरनल रेजिस्टेंस लेके कि उसको एक ही बैटरी में कन्वर्ट करना।
V1, V2, V3। मैं ये कह रहा हूं कि अगर तीन डिफरेंट है, 10, लेट्स से दिस इज 10 वोल्ट, दिस इज 12 वोल्ट, दिस इज 13 वोल्ट।
yes,
तो ये दो पॉइंट जो है, ठीक है, आपने इंटरनल रेजिस्टेंस ले लिया, ठीक है, लेट्स से दैट R1, R2 and R3। so if you measure the voltage between these 2 point, that will be some of fixed value, that will be not different, ठीक है। सो अगर आपने हाँ एक्सटर्नल रेजिस्टेंस लगाया देन इट कैन बी वैलिड, बट सबके लिए करंट की वैल्यू फिर कुछ और होगी, और इस तरह से होगी कि हम इस दो पॉइंट के बीच में वोल्टेज मेजर करना चाहे तो वो सेम आएगा। मेरा कहने का मतलब ये है कि मैं ये 9 वोल्ट बैटरी, फिर 6 वोल्ट बैटरी, फिर 3 वोल्ट बैटरी, इस तरह से मैं नहीं कर सकता, दिस इज इनवैलिड। अगर मुझे 9 प्लस 6 प्लस मुझे कुछ एलईडी ड्राइव करनी है, एलईडी ग्लो करना है, तो दिस इज इनवैलिड कनेक्शन। और अगर आप कुछ एक्सटर्नल वो रेजिस्टेंस लगा देते हो यहाँ पे लाइक दिस, लेट मी ड्रॉ इट ऑन अ फ्रेश पेज।
तो रेजिस्टेंस क्या ऐसा फर्क डाल रहा है? मतलब वो तो ऑब्स्ट्रक्शन ही दे रहा है, लेकिन फिर क्यों ऐसे हो रहा
एक मिनट, अगर आपने यहाँ पे एक्सटर्नल रेजिस्टेंस लगाया और फिर आपने कुछ इस तरह से कनेक्ट किया, सपोज दिस इज योर एलईडी, ओके, एंड दिस इज, लेट्स से दिस इज 9 वोल्ट, दिस इज 6 वोल्ट, दिस इज 3 वोल्ट, और इस एलईडी को ग्लो करने के लिए सिर्फ 3 वोल्ट ही चाहिए। आप समझना बात को, अगर 3 वोल्ट ही सफिशिएंट, ठीक है, तो पॉइंट ए एंड बी, वोल्टेज बिटवीन पॉइंट वी ए माइनस वी बी विल बी ऑलवेज इक्वल टू 3 वोल्ट। तो यहाँ पे जो है, ठीक है, यहाँ पे कुछ करंट फ्लो करेगा, ये मैंने तो चलो रैंडम वैल्यूज ले ली थी, लेट्स से इट इज 2 वोल्ट, क्योंकि यहाँ तो जीरो आ जाएगा, तो वी ए माइनस वी बी विल बी एग्जैक्टली इक्वल टू 2 वोल्ट। तो यहाँ पे जो करंट फ्लो करेगा, अब इस पॉइंट पे आप केवीएल लगाओगे, ओके, सो 3 माइनस आई इंटू आर, that is going to give you 2 volt. This is 6, so 6 minus, let's say this is I1, this is I2, this is I3, current flowing into the branch. So 6 minus I2 into R2, that will be again 2 volt, and 9 minus I2 into I3, sorry, I3 into R3, that will be again equal to 2 volt. तो उसका कोई फायदा है नहीं, आपको एग्जैक्ट वैल्यूज एक ही मिल रही है। अब आप चाहे उसको फॉर्मूला लगा के कुछ भी कर लो, क्या क्या कर लो, आपको इसकी जरूरत ही नहीं है, खाली इससे काम चल रहा है, ठीक है। हाँ, दिस इज वैलिड 9 वोल्ट, this 963, so that is going to give you 9 the total combination, okay, 15 से 18 वोल्ट। बट इसका क्या फायदा है? तो ये बेसिक कॉन्सेप्ट ध्यान रखना, अगर इस तरह का कोई कॉम्बिनेशन है और मैं आपसे पूछूं व्हाट विल बी वोल्टेज बिटवीन ए एंड बी, तो वो चाहे ये अलग अलग हो, ये सेम आएगा, ठीक है। रीजन ये है कि I1 I2 I3 इस तरह से फ्लो होंगे इनके थ्रू कि वो सेम कर देंगे, बचे हुए वोल्टेज को अपने रेजिस्टेंस के क्रॉस ड्रॉप कर देंगे।
ओके सर।
ठीक है, ये तभी मैंने कहा बहुत बेसिक कंसेप्ट है, पर बच्चे गलती कर देते हैं यहाँ पे, और सॉल्यूशन एंड में क्या होता है, सॉल्यूशन गलत हो जाता है।
ठीक है,
तो अभी करते हैं आगे सॉल्व। Okay, so let's say that D1 and D2 are silicon diode, and we will be assuming that Vk of silicon is 0.7 volt. Okay, so if yes, Rishabh, एक मिनट, ऋषभ नहीं है भैया। So if first thing, if E is less than Vk1, okay, अब दोनों डायोड पैरेलल में, both the diodes are in parallel, so we don't need to add their sum, okay। यहाँ पे सिंपल कोई इक्विवेलेंस फॉर्मूला, कोई काम नहीं, कुछ नहीं लगाना है यहाँ पे, और वो लगता भी नहीं है। सिंपली इफ E इज लेस देन Vk1, क्योंकि अभी यहाँ पे हमने कोई रेजिस्टेंस अज्यूम नहीं किया है, तो इफ E इज लेस देन Vk1, D1 and D2 will be off, and this will be the equivalent circuit. Simple, like this, open circuit, and I is 0. Second case, if E is greater than Vk, so D1 and D2 is on। अब आपसे मैं पूछूंगा वैल्यूज, this is E, this is plus minus Vk, this is again plus minus Vk, and this is the complete circuit. So now please tell me what will be the value of I. अब यहाँ पे दो है Vk Vk, क्या करोगे, इसको कंबाइन करोगे या कुछ अलग लोगे? Anyone? वैसे भी 2 मिनट है। मंदित, we have 2 minutes, तो यहाँ डिस्कस करके
सर एक ही मान सकते हैं अगर पैरेलल में?
ऑब्वियसली एक ही मानना पड़ेगा हमें, कोई कनेक्शन एक ही मानना पड़ेगा। और यहाँ पे अगर मतलब दिस इज नॉट वैलिड अगर मैं यहाँ D1 लगा दूं सिलिकॉन का, यहाँ जर्मेनियम लगा दूं, ठीक है, तो इट इज अ काइंड ऑफ नॉट वैलिड कनेक्शन। पैरेलल में अलग अलग वोल्टेज सोर्स नहीं लगाया जाता है। सो द वैल्यू ऑफ I कैन बी गिवन बाय सिंपली ओम्स लॉ। I कैन बी गिवन बाय E एट दिस पॉइंट। अगर इस पॉइंट पे आप वोल्टमीटर लगाओगे, दिस इज पॉइंट A एंड दिस इज पॉइंट B, तो यू विल बी गेटिंग Vk। इवन दो 1000 इनफाइनाइट Vk पैरेलल में लगा दो, कोई फर्क नहीं पड़ता। Va and Vb will be always be going to Vk, so you will have E. Simple, you are applying Ohm's law. So at this point of R, you have voltage E. At this point, you have Vk. So E minus Vk divided by R. That what I was saying, that even though hundreds of multiple sources are in parallel, इसके बीच में एक ही वैल्यूज होगी। तो वो जो भी था आपका, मे बी आप कुछ और सेंस में बात कर रहे हो, मैं कुछ और बोल रहा हूँ, मे बी यू आर राइट, बट मेरा कहने का मतलब ये था, मैं इस कॉन्टेक्स्ट में बात कर रहा था।
सर कभी मतलब क्वेश्चन में तो हम ऐसे एक्सपेक्ट नहीं कर सकते ना कि डिफरेंट वैल्यूज आ जाएंगे।
आएगा, करेंगे उसको, अभी टाइम खत्म हो गया है। नेक्स्ट क्लास
अच्छा।
में हम वैसा सर्किट लेंगे कि एक जगह सिलिकॉन लगा होगा, दूसरी जगह जर्मेनियम लगा होगा, उस
ठीक है
केस
सर।
में फिर क्या करना है देखेंगे हम। तो
ठीक
नेक्स्ट
है।
क्लास में यही करेंगे और फिर आगे हमारा रेक्टिफायर स्टार्ट करेंगे। ओके, सो हैव अ नाइस वीकेंड, सी यू ऑन ट्यूसडे।
थैंक यू सर।